We're going to be looking at the rational zero theorem for this video. It should be a very short one. If p of x is a polynomial function with integer coefficients, so whole numbers, and p is a factor, well, positive and negative whole numbers, and p is a factor of the constant, and q is a factor of the leading coefficient, then the fraction p over q is a possible rational zero, and this is called the rational zeros theorem. So I'll give an example, try and get a fairly large example. Can you make a list of all the rational zeros, the possible rational zeros? So no one is going to say that our list contains any actual ones. We can't guarantee that, but we can make a list of possible ones. So what we will do is p is a factor of the constant. So you can see all of my coefficients here are integers. P is going to be a factor of the constant. P will be a factor of negative 30. So what could we have? We could have 1 times negative 30, or negative 1 times positive 30. We could have 2 times 15, or we could have negative 2 times positive 15. We could have 3 times negative 10, or negative 3 times positive 10, negative 5 times 6, or positive 5 times negative 6. So I've written them there in order and plus or minus. Now q is a factor of the leading coefficient. The leading coefficient is 5. What are the factors of 5? I could have 5 times 1, but I could also have negative 5 times negative 1. So that's going to be my possibilities for p and q. And what are the possible rational zeros? Anything I can write as p over q. So what I'm going to do is I'm going to make a list, and this is how I like to do it. I'm going to go through the q's separately. So suppose q is plus or minus 1. So if I've got plus or minus 1 in the denominator, well, the 1, I'm just going to get these original ones back. So if I have plus or minus 1 all over plus or minus 1, well then first of all the plus or minus 1, I can bring that out to the front. But of course, since I have 1 in the denominator, it's just going to be plus or minus 1. So plus or minus 1 over 1. Plus or minus 2 over 1, which will be plus or minus 2. Plus or minus 3 over 1, which will be plus or minus 3. Plus or minus 5 over 1. Plus or minus 6 over 1, plus or minus 10 over 1, plus or minus 15 over 1, and plus or minus 30 over 1. Now I'm done with the 1 in the denominator. I have another possibility for the denominator, and it's going to be plus or minus 5. So I'm going to go back and form all of these fractions p over q. I could have plus or minus 1/5. I could have plus or minus 2/5. I could have plus or minus 3/5. I could have plus or minus 5/5, but that reduces to plus or minus 1, and it's already in my list. I could have plus or minus 6/5. I could have plus or minus 10/5, but that reduces to plus or minus 2, and it's already in my list. So I'm not going to write it again. Plus or minus 15/5 is reducing to plus or minus 3, already in my list. Plus or minus 30/5 is plus or minus 6, already in my list. That is my complete list of possible rational zeros. Some of them might be an actual zero, or I might be very unlucky and none of them are. But at least I do have a list. And that's the end of this video.